Hello, everyone. Thanks for coming. I know a lot of you have the interspeech deadline coming up, so glad you're here today. I'm really happy to introduce Cindy Wang. She's at Google now. You've been there a little over a year and a half, right? So she got a PhD from CMU under Graham Newbig. And for those of you who don't know CMU, Graham Newbig is the advisor everyone in LTI wants to work with, and I think she was one of his most prolific students. You were an Apple fellow, right?
Yeah.
A PhD fellow, and before that, she was a undergrad at Notre Dame, where you were the outstanding CS graduate, right?
Oh, wow. I
Yeah,
forgot about that. Thanks.
yes, she was. And she took the NLP course when I was a grad student as the TA. So that's how I know her from years ago. So excited to hear her talk. She does a lot of multilingual NLP stuff and large language models and doing some cool stuff at Google. So let's welcome Cindy.
Thanks, everyone. Thanks, Kenton, for introducing me and inviting me here. Yeah, I'm really glad that I can have the opportunities to talk about building reliable and data efficient applications with large language models. Yeah, so let's get started. As we all know, large language modeling has been a pretty classical task that's been studied by the academic community for a long time. But in the past 2 years, they have become they've become a very popular tool really quickly that changed many people's daily lives. We all use ChatGPT now, and mostly I use it for coding, and it's been really helpful to increase my productivity. And more recently, Google also launched a summarization-based search system where you give it a query, it would generate a paragraph that summarizes some search results. And on top of that, they are also transforming our professional lives. There are a lot of startups nowadays trying to deploy these LLMs and the tools into real-world workplace, like search for different companies and company-specific code search. There's also efforts in building tools for very lucrative professions like lawyers that's aiming to make the law professionals more productive and accessible for more people. However, while they are becoming more and more popular, it could also lead to a lot of risks if we are adapting them so quickly into our daily lives. One of the most important problem is that these LLMs can make really plausible mistakes that are often hard to identify. And this could pose really huge risks if we are using these applications for important professional fields like lawyers or financial industries. For example, I don't know if people have heard of this. Apparently, Air Canada is putting a pause to their chatbots because it gave false information to a customer that lead to them have to pay a large fee to compensate for the misinformation. Another risk is that these general chatbots could also are trained on general web data, and they could struggle with specialized use cases. For example, we all use Gemini and ChatGPT, right? But if we want to deploy them to specialized fields, there are also efforts required to adapt them to medical fields or like professional financial fields. Moreover, these models are trained on predominantly English data. So if there are users speaking different languages, it's hard to provide the same level experience to diverse users. So how do we make these LLMs more reliable and cater to a more diverse audience? So to answer this question, we can first take a look at the different LLM development stages. So in general, we have 4 stages of development. First, pre-training just pre-trains on a large corpus of web data. And next, we would go through supervised fine-tuning, where we provide it with high-quality human instructions that provide some signals about how we want to make this model behave in a specific task. And after that, we can also provide additional reinforcement learning or human preference signals that further improve the performance. And after we train the model, we also need high quality human judgments or preferences to help us evaluate and understand how well these models are. And if we look at this whole process, it's actually bottlenecked by high quality human data or high quality data in general. So in this talk, I will try to break down some approaches that we are developing to build more reliable applications by making use of limited amount of training data and also building evaluation systems that help us to understand how reliable these systems are. So I will first talk about utilizing limited training data to build sparse and compositional models that help us to adapt to different use cases, and also a novel evaluation system that help us to evaluate the factuality of these large language models. So first, in the first project, we focus on adapting LLMs to different use cases. So when we have a pre-trained model, we usually want to deploy it to different users in speaking different languages, or in different specialized tasks, such as question answering, summarization, or coding. However, if we are trying to expand the model to a new language, how can we deploy it or make it better for this new use case? In general, we would have to collect more golden data to help us train the model better or help us to evaluate the model better. But is there a way that we can make this process faster so we don't have to spend way more budget on collecting these new data? And in general, the traditional approaches of adapting large language models rely on parameter efficient tuning. If we have these data sets in different languages or different tasks, a standard approach is just to fine-tune a model or a small amount of parameter on each of the specialized data set. This would require a separate module for each task, and it also requires a more engineering effort because we have to run individual training runs, and there's also limited positive transfer between different languages or different tasks that we can utilize. Another approach is to just mix these data together. This would make this process way more simple, but it also has a limitation where it could lead to negative interference between different tasks. And in both of these methods, it's unclear how we can quickly adapt the model to a new use case or new language. So here in this project, we try to understand whether we can design a better parameter efficient tuning method that allow us to quickly adapt to a new use case using existing these large mixtures of different tasks and languages. So actually, our proposed method is very simple. We're still using one training run on a mixture of different tasks and languages. This allows us to reduce the engineering effort because we only need to run the training once. However, during training, we can assign different expert modules to different aspects of the dataset mixture, such as expert modules for different tasks like question answering, NER, and there are also expert modules for different languages. So for each of the languages in the training mixture, we can assign a specific expert to be responsible of representing that data. And at inference time, it actually allows us a very natural way of doing zero-shot generalization. So during training, even if we don't have a QA data in Tamil, for example, we could still compose the pre-trained experts so that it can generalize better to a zero-shot setting. And furthermore, if we're encountering a language that doesn't exist in our pre-training mixture, we could also select the task module so that the model can better utilize the task information in our tuning mixture. And in this work, we experimented the setup on the Extreme Up benchmark, which is a massive multilingual benchmark covering different tasks and covering a wide range of languages. And we experimented with multilingual multitask tuning and also joint tuning, where this is the most preferred case where we only need one training run to support different tasks and languages. We also compared with different baselines with parameter efficient tuning, where the compute match baseline simply means that, yeah. Okay, cool, yeah. Yeah, so for the compute match baseline, this simply means that the number of LoRa parameters is equivalent to the number of activated parameters for each dataset. Because even though we have a lot of predefined experts for each training example, we might only need to use a small amount of parameters. And for the parameter match baseline, we just match the LoRa parameter to be equivalent to the whole amount of parameters we added. And what's your question?
If you go back to the previous slide, I wanted to know what you mean by the plus when you combine these adapters.
Right.
Are you combining the weights? Are you combining the outputs? Are you doing it at the level of the whole model or at every step? What exactly does plus mean?
Yeah, that's a good question. So for this, the plus simply means adding this parameter back to the added parameter back to the original model weights. So in the feed for
the model weights.
Right.
Okay.
Yeah.
I could imagine having both adapters and combining their outputs or something.
Yeah,
stage by stage.
Yeah, that is also an option. But I guess like if you are merging these parameters back to the original weights, you don't have to do additional compute. You can just feed the model through one single parameter once.
Right. Yeah. No, but on the other hand, then it means that all of them have to be the same dimension.
Right. Yeah, that is the.
May or may not be true. Which may not be optimal. I don't know. That's why I just want to know what you meant. I'm not challenging you. I know nothing.
Yeah, makes sense. I think that's definitely a concern, and you're right. It has to be the same dimension as the original parameter.
Got it. Thanks.
Yeah, so we tested this method on fine-tuning POM2, which is a decoder-based large language model on the multitask multilingual mixture, and we found that it consistently outperforms all baselines, and especially in the zero-shot setting, which shows that this method is really good for generalizing to unseen use cases. And here is also a simple analysis where we try to find out whether our method can perform better for to support diverse use cases. So essentially, when we are just training the model on multitask training, so all the data coming from the same language, it generally performs worse than training the model on many different languages. This is because we have limited capacity and there's negative interference between the data sets. And we can see that for the standard baseline, it generally leads to some decrease in performance, versus our method is able to scale well to increasing number of data sets. So in conclusion, here we propose specialized expert modules that allow us to adapt LLMs to diverse use cases and generalize better to unseen use cases. However, there's also additional work that needs to be done to potentially make this method more practical. One concern is that this method would require us to have language or task ID even at inference time. But in real user use cases, there could be code switching, there could be undefined language boundary or task boundary. So it's also very interesting to understand whether we can learn a router based on these trained modules to automatically route each queries into different expert modules. And additionally, although in this paper, we found that we have these expert modules that we can use without incurring a lot of, theoretically, a lot of computational cost, but implementation-wise, we still need to design a better implementation so that we can actually take advantage of the sparsity in terms of these individual experts. Now that we finished discussing better tuning methods for multilingual multitask mixtures, next I will move on into designing better evaluation data and methods for large language models. So here I will focus on the question answering system, which it's also been studied by academia for a long time. And the traditional approach is simply taking the large language model, feed it into a query, and it generates a short answer. And a lot of times this short answer is like a extracted sequence from a provided passage. And to evaluate this system is actually, there's actually a very simple metric where we just compare the generated answer to the gold answer. And this gives us sort of an accuracy. However, in 2024, the QA system has changed a lot compared to the old system we experiment on. And in general, given a query, the user would expect a statement that can cover the instead of short answer. So they expect sometimes even a paragraph containing multiple statements. So this new system actually makes it very hard to measure the quality of our QA system. If we are still using the exact match, then this could lead to a lot of wrong measurements where maybe the correct answer, where the answer is correct, but it's not exactly matching the gold answer. And there are multiple aspects in measuring this generation. We should measure how fluent it is, whether the presentation is good, whether it's actually providing informative information to the user. And one of the most important aspects of measuring the system is actually factually correctness. Because you are giving it a question, you definitely want it to give you the correct answer. So how do I measure factual correctness for this kind of QA systems? There's actually some metric that's being proposed for language generation called attributable to identified sources. So this actually fits really naturally into a QA pipeline in 2024 because given for the current QA system, we usually retrieve relevant sources and then ask the LLM to generate an answer. And one way of evaluating the factuality is just to look at whether this statement is being supported by one of the sources. And this is essentially a binary classification problem. And in particular, in this work, we're trying to see if we can develop this metric for multilingual question answering using a retrieval-based QA system on the XOR QA dataset. Yeah, so using attribution as a metric for QA has a lot of advantages. For example, it recognizes paraphrases, so we don't have to rely on exact match. It also measures the groundiness of the answer. However, this would be very expensive in practice because it would require human annotation to look at the generation, look at the evidence, and then give you these measurements. And if you want to develop a system and every time you want to measure the factually correctness, it will cost a lot of money to every time ask the human annotator to give you this factuality evaluation. So we also wonder if we can actually just train a model to evaluate the attribution of language models. So in this work, we collected a dataset called XOR AttriQA dataset using multilingual question answering datasets. And given the retrieved passage and the answer generated by the system, we asked human annotators to answer whether to answer this binary question, whether this generated answer is supported by the retrieved passage. And we conduct this data collection in 5 different languages, resulting in a human annotated evaluation dataset for cross-lingual question answering. Yeah.
Good. So was this based off of XOR QA because you had that on the previous slide, or is this novel? The question answering data?
Yeah, the question answering is based on XOR QA. So it's using an existing QA dataset, but we added the retrieved passage and human annotation.
Yeah. Follow-up question, why XOR
QA? Because I guess mostly because XOR QA is has a lot of good language coverage, and it also the questions are somewhat culturally relevant, so we selected. Oh.
Yeah, what happened because
okay, let me share the screen a bit. Okay, cool.
Okay, I had a question about,
yeah.
Could just go back to the slides.
Yeah. Which one?
Yeah, that's not good.
Right.
So if I just look at this setup of your problem, right? You have a query passage and answer, and the decision you're going to make is the answer to the question supported by the passage.
Right.
If I drop the query and I just look at the passage and the answer,
right.
couldn't I treat this like a textual entailment task?
Yeah, that's a
And
very
then
good
use
question.
existing textual entailment system to see if the answer is entailed by the passage?
Yeah, that's a very good question. That's actually one of our methods to build this model-based attribution evaluation.
Okay.
But I guess like we could look at the passage and the answer. It's also important to look at the query because we want the answer to be relevant to the question.
Okay.
Yeah.
And I guess here I'm only thinking about whether it is supported by the passage, and its relevance to the question is the QA task.
Yeah, that's true.
So if you're looking at, okay.
Yeah, that's a good point. I guess like this is a complicated question that needs multiple aspects of evaluation.
Okay.
Yeah. So like exactly as you mentioned, one of the ways we can build this model-based attribution evaluation is using natural language inference data. So essentially we have these first two methods are more like the classical methods. The first one is string matching. Essentially, we're just checking whether the answer exists in as a substring in the retrieved passage. This is a very simple heuristic baseline. And the second one is using MT5 data, and we tune it on around 1 million natural language inference examples as a way to evaluate attribution. And additionally, because we collected this human annotation data, we also tried using large language model itself through few shot prompting and fine tuning as a way to build it as an evaluation model. And here is a breakdown of the performance, and we can see that NLI, MT5 tuned on NLI is pretty good, but it requires a lot more training data. And using large language models with just maybe 100 tuning examples, it achieves the best performance. And few shot prompting is also reasonably good, but I guess I didn't annotate on the slides. The few shot prompting is using the largest model, and the fine-tuned POM2 is on a reasonably smaller model, so it could be more efficient to use in practice.
In clarification question here, accuracy means that the answer is both correct and is attested in the passage.
Yeah.
It's not measuring only the correctness of the attribution, it's also measuring the correctness of the answer itself.
Yeah, I think here we are focusing mainly on attributing to the source. So you might be right, like we are not like looking as closely as whether it answers the question, but by looking through the data, actually, because the actual QA is a relatively simplified question data set, so most of the answers are pretty relevant to the question. But
passage is relevant, so if you get
yeah.
Well, the answer is relevant, so if you find the passage right.
Yeah, but that's definitely another aspect we should look at when evaluating the more complicated QA situations. So here in this work, we proposed a factuality evaluation data set for building more reliable multilingual QA models. And there are also a lot of limitations to this work. First is here we are mainly looking at attribution, just looking at whether the answer is supported by one of the retrieved passages. But one could see that maybe we retrieved the passage, but that passage is not actually objectively correct. Like it could be outdated, or the information might be outdated, or the information is out of context. And in that case, it would become a much harder problem to measure factuality. Another important question is collecting culturally relevant queries. Here we are using XOR QA, which is reasonably culturally relevant, but there are still a lot of hard location-specific questions, and we really need a better data set to measure how well these models do in location-specific question answering systems. So yeah, this basically sums up the two aspects of direction in building reliable applications for diverse users. And basically, we try to propose a sparse and compositional model that allow us to adapt to new use cases quickly. We're also trying to build a evaluation data set so that we can make more reliable question answering systems. And there are still some interesting future directions in terms of building more reliable applications. First is that we still need a lot of research to accurately quantify and reduce model hallucinations. And in order to reduce model hallucinations, first we need to be able to measure hallucinations. There are actually many nuanced ways of defining factuality and hallucinations. So we probably need better ways of categorizing these different cases. And one of the bottleneck of factuality evaluation is also human data collection. Because when we go beyond attribution, there could be a lot of cases where we need to ask humans to look for information online. And that could be very expensive and maybe also requires more radar training or ways of using language models to assist humans to make better decisions. And we also need more novel methods to reduce hallucinated generation. Now it seems like RAG or retrieval augmented generation can reduce a lot of hallucination, but it's definitely not enough. I think we still need more better understanding and more novel methods to make the generation more reliable, such as developing better RLHF methods for factuality, or understanding what kind of pre-training data or like tuning data is making the model hallucinate. And additionally, we also need to develop data-efficient adaptation methods for more diverse use cases. One of the most promising approaches is using synthetic data. It seems to work really well, but I think there's also a lot of room for improvement and also understanding the trade-offs between exactly how synthetic data would help on top of human data. Yeah.
I had a question there.
Yeah.
Synthetic data across languages, like does English synthetic data work better?
Yeah, I think I guess I'm pretty sure it would be better to generate synthetic data in English compared to low resource languages, or not even low resource languages, but languages maybe using a different script. All kinds of Indian languages or like Japanese, Korean would also be slightly worse.
My question is, like, we need synthetic data because we don't have enough data, but our synthetic data generation works on models that we have a lot of data, right? So
right.
It's kind of this chicken and egg problem.
Yeah, for sure. Yeah, so I think there's we probably still need some amount of human data, but understanding like the trade-off of how much human data you need versus synthetic data would be a pretty interesting problem. Yeah, and on top of that, because now we rely on really expensive human annotations, so developing better active learning, finding out the examples that are most relevant for our task could be also very important. And finally, just in general, any methods that can lead to more efficient utilization of these limited training data could be really helpful for developing good applications for very nuanced use cases or users, low resource language speakers that where they don't have a lot of training data. So that's all for my talk. Thanks for listening. And if you have any questions about any of the things I discussed, feel free to email me. Thanks.
We have time for quite a few questions, so if anyone wants to go, I have a lot more to ask, but.
So for the attribution portion of your talk, my understanding was that you're trying to build a component to help us better understand to design the process of this black box QA system, what is it that is able to think from that retrieve document, what is it entails to contain and the states and so on. But then your solution was another black box. It feels like you've shifted the problem from one black box to another black box.
Yeah. I guess you're right. In that sense, the motivation is not really actually solving the factuality problem. So in my talk, it's mostly an evaluation framework. So I guess like if you want to solve hallucination, you first need to understand how hallucinated your model is. And that requires developing understanding a definition of what is factuality you're measuring, how to collect human data. That's the first step. That's usually actually is quite missing from the research community, also in industry as well. There are some like methods of collecting human data, but that human data is used to evaluate whether the model is good or not based on that signal, and then we can make more improvement on top of that, such as using RL or something like that. But yeah, you're right. It is using a black box, but the black box we're developing is more like a very specific, it's accomplishing a very specific goal, which is to measure how good the model is. Yeah.
I had a small question. So
Yeah.
when you were doing some of the things, you had overall accuracy, as an evaluation, but do you have an idea of like how things work better on different languages? Again, I have a lot of multilingual questions here. Like your score was like 94 or something, right? Was that like close to 100 on English, and is it like a 75 on like television or standard or something like that? Or...
Yeah, that's actually all non-English performance. Yeah.
So is there a difference by I think maybe data set size or language resource size or language family? Do you have any idea on that?
Yeah, I guess well, we actually our work is very limited. It's not performed on a wide range of languages. It's only 5 languages. So actually, in my impression is that it seems like the model is surprisingly good at detecting factuality if you give it some amount of examples. So that's actually a good thing, a good signal, which means that maybe we could develop a reliable evaluation just using a small amount of data. And we should use that to further improve the model.
I had a different question maybe about this approach to, let's call it verifying factuality, although you clarified that what it really means is you're verifying that there is one source in which the answer is attested in some form, right?
Right.
So this is fine. One of the things I was thinking when you were showing us this is that the generative model that we have today appeared to sort of, do some kind of reasoning on all the text they read, and they might synthesize an answer using assertions made in different documents in different places.
Yeah.
Or at least to the extent they do, that's why we like them.
Right.
But then again, like, they hallucinate and do all sorts of other things.
Yeah.
So how do you see this framework extended to an answer which is correct, but not attested in one place? That it requires, like a human would require some reasoning. I'm not saying that these things do proper reasoning in the sense we think of reasoning.
Right.
They do something.
Right.
How would you extend this framework to that? If the answer was correct, but not really attested.
Yeah, that makes sense. So if I understanding correctly, you're saying like if the answer is from multiple sources, how do we? Yeah, so that's actually a real problem. And I think in general, verifying whether one, so like in that case, then maybe the sentence you're generating or like the paragraph you're generating has multiple claims that you're trying to verify. So probably like the first step is to decompose that generation into multiple claims you want to verify, and then this framework could extend to that because it's basically measuring each of the single claim, if that makes sense.
Yeah, okay. So I mean, I think my problem is backwards in the sense I don't know what those multiple claims are.
Right.
They've all been synthesized. Like, Obama was president and he had two daughters, and the elder daughter was named Malia. And Malia went to Brown, or whatever that sequence is, right?
Yeah.
And then, like, if you just ask which school did Obama's older daughter go to, and the answer is Brown. Then I need to find 3 or 4 different places that I don't know what the chain of reasoning was.
I see. So you're saying the passage is actually contains a lot of information and.
Or that there are many passages with pieces of the.
I see. Yeah, I guess like here you are trying to verify whether Maria went to Brown.
Yeah.
That is one single claim you're trying to verify, right?
Yeah, exactly.
Yeah. So in that case, like probably you would want to extract those atomic claims and like if you are still using attribution framework, you would look at the passage and see if there's evidence supporting this.
Because another way to do it possibly would be to have, at some point in the future, some kind of knowledge base where all this extraction happens ahead of time.
Right.
And you check for attribution against. Is there any work in that space to check for attribution to a knowledge base rather than to a document?
Yeah, I might have seen it somewhere before the ChatGPT phase. I think there's definitely some work that's using knowledge base as a grounding tool for some sort of system, but I'm not super sure if it's for question answering. But I think it definitely exists, but it's like from a long time ago, and I agree this is probably some important direction.
You can't say that someone at DeepMind is working on it.
I cannot verify that claim. Yeah. Based on my own personal knowledge base, I cannot verify that claim.
Yeah, okay.
So.
You're not hiding it. You're saying you just don't know that.
Yeah.
No, it's a big organization. So.
Yeah.
Any other questions?
Yeah.
So it seems that the attribution comes from when the model is able to conclude the correct passage, but unable to generate the correct answer.
Right.
My understanding. So I think that it also comes from the model inability to utilize its context. So for example, if we have like a in an ideal scenario where we have like a very good model which can utilize very long context, which is probably solve things. So like the solution lies into like making our models better at utilizing the context.
I see. Yeah, I guess that would definitely solve if you can build a system that's 100% correct at utilizing your context, then yeah, in some sense it already solved part of the factuality issue in terms of grounding, because now you can ensure the generation is definitely grounded in your context. But there are also other issues like maybe your document is not the relevant information, or like the document is outdated, then in that case, you still need some ways to verify whether the answer is factual. So I guess the answer is yeah, it does solve the grounding issue, but we also probably need a more sophisticated factuality measurements on top of attribution.
So you talked about like sometimes the retrieve passage are not like. I think that like the current way that we treat the retrieval like augmented generation, that the way that we treat is we do the in-batch negatives, right? So we have like a batch and we have the correct one being on the diagonal and other incorrect one being off the diagonal.
Right.
Is there like a way that we can make better batches such that the retrieve passages are kind of hard negatives to improve the systems? This is something I've been thinking about, is that the current way that we train our retrieval augmented generation models is that we just throw everything at a single batch, and maybe the passages are very easy to discern, and it's easy to pick up like a gold passage out of like multiple diverse passages. Is there a way to like construct the harder negatives or even find harder negatives utilizing say representations or even large language models? I think this is
Yeah, I think that's interesting. That's an interesting idea, and I think it definitely has potential to help with the model. So essentially, you're saying we want to when we train the generative model, we want to give it hard in-context learning examples so that it can discern between using the correct one and the incorrect one.
Yeah, so I'm saying that the contrastive learning framework, we can get harder negatives. I think it also boils down to selecting harder examples or selecting training examples. It also connects with what you're saying in the future directions, the active learning framework.
I see. Yeah, I guess one issue with the current framework is you already trained the generative model and you are just adding retrieval on top of that. So I can see like maybe you could continue training the generative model to be able to better use the context. Yeah.
A third question will be like in the future direction you talked about active learning, but it's actually like a very expensive process. What would you do to make the process more scalable? The repetitive labeling and training process. How would you do to make it more scalable to the current language models?
Yeah, I think that's probably an open research question. I think there are actually more work on active learning. Maybe last year there are some like more theoretical papers on active learning for reinforcement learning. Yeah, so I do think this is a interesting direction, like because we probably want to find out what are the prompts or like questions that are most informative for the model to learn from, and then those examples we can maybe ask the human annotators to annotate and then give the model better signals. So I guess that's the general intuition, but I'm not sure I have like a very clear method going forward, but I think this is an important problem because then you can potentially save a lot of annotation budget and also make the model more efficient at using a small amount of annotation to learn better.
Thank you very much.
Yeah. Thanks for the question.
So about the first work that you showed about the expert modules, is there like, so in the context of sort of general purpose LLMs, so the user could do anything at it, is there some kind of analysis of some ideas of yours about what's a good way to assign domains for the experts, like how to split up basically the input space into these domains, or like by language or task, or the interplay between these things?
Yeah, that's a good question. So I guess like in the talk, I was mostly focusing on different tasks and different languages, and domain is another dimension. There could be many different dimensions to define the data set. So I think here I'm using a more simple approach because it is more efficient. So I guess like you could try to ask the model to automatically learn which expert it routes from during training time. And that's essentially a mixture of experts or different ways of mixture of experts. I think here I choose to like have specialized routing during training time with task and language ID because it is simpler. It's like it gives us very clearly defined expert modules for different aspects of the data. Then you can perhaps use them at inference time and use them to generalize better to an unseen use case. Yeah, so I think like there are a lot of interesting directions on deciding how to better use mixture of experts. But I do maybe I have a bias on like designing something that's more simple, so it can like just at training time, if you have those information about different domains or different languages, then you can use them. And maybe after you train the model, you could learn a better way or like a smarter ways of combining them. It's not clear which one is better, I guess I'm just proposing like a solution where it's potentially simpler to use in practice. Yeah.